Moving on to the last and final concept of the mesh analysis is the super mesh. So as you can recall from the videos of the nodal analysis, that whenever we encountered voltage sources in our circuit and we were applying the nodal analysis, we used this concept called the super node. And I also told why it was so necessary. So the same is the case in the mesh analysis, but here the problems occur when there are current sources present. So the first thing to know is, why is there a problem when current sources are present in a circuit and you are applying mesh analysis? So let's just look at an example. So as you can recall from the videos of the sources, the main characteristic of a current source is the current. Now, whatever the voltage across this element is, and there would be a potential difference across this element, because all electrical circuit elements, they have a potential difference. So this voltage, this can be anything, and the current would still be the same. So this is a problem when you're applying the KVL, because if you encountered a current source and you're just moving clockwise in the loop, you won't know what the voltage across that source is. So you need to have another concept of deriving the KVL equations. So let's just look at an example and apply the super mesh analysis. Alright, so this is an example of a circuit that contains a current source of 3 amps, and we need to apply the mesh analysis, for example. So the first thing that you need to know is to identify the meshes. So this is the first mesh, I1, and this is the second mesh, I2. So now I can clearly not apply a KVL on mesh 1, because I would have to pass through this current source and I do not know the voltage across it. I can also not do the same for the mesh 2. So what you do in this case is you form a super mesh of basically the two meshes that contain the current source, and in this case it's mesh 1 and mesh 2. So the super mesh is called SM12. I'll just call it SM12. So I'll now apply the KVL on SM12. As you can recall from the videos of the super nodes and the nodal analysis, whenever we were applying a KCL on a super node, we just ignored the part where the voltage source was. So we'll just do the same here, and we'll ignore this entire branch, and we'll apply the KCL from here till here, ignoring the middle branch. So let's just start from here, and I can see that there's a negative sign, -2, and then there's this resistor and there's a current of I1 going through it, so +2 I1. I'll just ignore this branch and I'll move here, and now there's this resistor 5 ohms, and there's a current of I2 going through it, clearly because this is the periphery of the second mesh. So +5 I2, and then there's a negative polarity, so -1 is equal to 0. So now I have an equation, but the problem is there are two unknowns and there's just one equation. So I need a second equation, and this is very simple, and I'll show you how. So I can clearly see that this is a 3 amp source going up, and I also know that there's I1 coming down in this branch, and there is I2 going up because of the clockwise direction. So as the current is in I2's direction, I can clearly subtract both currents, and I can write that I2 minus I1, that is clearly that is clearly 3 amps, because there is I2 going up and there is I1 coming down, and the way I get these two directions is because of the clockwise convention I'm using. There is I1 flowing clockwise and there is I2 flowing clockwise too. So I2 will just go up and I1 will come down, and I can use those two directions to subtract these two currents to get 3 amp. So now I have my second equation, and now I can easily solve the circuit to find the actual currents. So this is how you form super meshes. Now I'll just show another example with the current source at the periphery of a mesh. Alright, so I have this circuit now, and there's just this slight difference that the current source is not between an intersection of two nodes, and it is just at the edge of, or at the intersection of two meshes. And in this case the current source is just at the edge of a mesh. So I'll just identify the two meshes first, and there are two meshes, I1 and I2, and I need to find them. So and like in nodal analysis, when our voltage source, it contained the reference node, we just did not write the KCL for that. So it's the same for this case. When the current source is at the periphery of a mesh, you do not write the KCL for that mesh. So a KVL for that mesh. So I'll just write the KVL for the other mesh, which is I2, and I'll start off from here. Move clockwise. There's this negative sign, then there's this 5 ohm resistor and a current of I2, and then there's 1 volt voltage source. So this is my equation. And I can easily find I2 from this because I can just move the 6 to that side, and I2 would be 6 by 5 amperes, and this is simple algebra. But how do you find I1 then? I've already found out I2, but there is no equation for I1. So if you look very closely, I1 is this current moving clockwise. This current is clearly 2 amps. This is what this current source is telling us, that the current through it is 2 amps. So I1 is clearly in the direction of this current. So I1 would be 2 amps. So this is how you can simply find the currents using mesh analysis when the current source is at the periphery. And if in a case the current source is between the two meshes, you will have to form a super mesh. And in the next video, I'll solve another practice problem to make things even more clear.